Hello and welcome to lesson 3. Today we're going to talk about different types of estimates during the design phase of a project. We're going to talk about the comparisons and what the differences are with the accuracy of the different types of estimates and how long it takes to prepare these different types of estimates and how you handle contingency. So we're going to start off with the rough order of magnitude estimate, then we'll get into the square foot estimate, and then in this lesson, we will also cover the assemblies estimate. And then we'll wrap up with a real world story about estimating a renovation project. And a renovation project can be a real challenge as compared to estimating a new construction project. So let's get started. In this lesson, we are going to talk about estimating time for a $10 million project, rough order of magnitude estimating, square foot estimating, assemblies estimating, and assemblies estimating by division. We talked about these topics earlier, but now let's dig in and get some more details. First, let's revisit the estimated time required for an approximate $10 million building. An order of magnitude estimate could be 10 or 15 minutes. A square foot estimate could be 1 or 2 or 3 hours. An assembly estimate could be 1 or 2 days. And the very detailed unit price estimate could be as much as 3, 4, or 5 weeks. So let's talk about each one of these in detail. In particular, order of magnitude estimate, square foot estimate, and assemblies estimate. Let's talk about a rough order of magnitude estimate. In the conceptual stages of a project, very little is known about specifics. Design information may only contain sketches or concepts. Descriptions are generally in terms of capacity, such as the number of hotel rooms, hospital beds, or parking spaces. Rough order of magnitude, or sometimes referred to as ROM estimates, typically establish a cost per unit of capacity. These units are developed mainly from past experience and past projects. Examples are cost per bed for a hospital, cost per apartment, cost per pupil for a school, or cost per mile for a highway. By multiplying this cost times the number of units proposed for the project, a preliminary number can be established. If the costs are developed according to a national average, they must be adjusted using the appropriate city cost index. Costs taken from past projects must be adjusted to current or future dollars. If the project is similar or larger than normal, the cost is adjusted for size. An appropriate contingency should also be applied to allow for scope adjustments and economic or market conditions. As with all estimates, the accuracy of a ROM estimate depends on the quality of the data used. If the company doing the estimate has good historic database information of similar projects, that is the best source for that information. If these data items are not available, there are nationally published databases that can be consulted with. One advantage of a ROM estimate is that it can be calculated quickly, very quickly, often in minutes or hours, and is typically assumed to have an accuracy of plus or minus 20%. This quick turnaround can enable an owner to look at several options without having to invest too heavily in any one, including not having to invest in a lot of design work. These estimates are often the first costs that an owner sees. Although they are normally accomplished with little information, the number put forward at this time tends to be the number that the owner remembers, and consequently, all estimates that follow are compared to this. It is therefore important for the estimate to be qualified. All assumptions should be listed and all information considered identified. In the early stages of project development, this type of estimate is an important tool, but its limitations must be fully understood and articulated. So these are some of the basis for historic data to come up with costs per unit. And they're all within about 20% accuracy.
Hi, I hope you're enjoying this free lesson from the University of Maryland's Project Management Center for Excellence. If you want to check out more lessons just like this one, click the link in the description below where you'll be able to go to our website on executive project management. There, you can find edX courses, professional short courses where you can learn from an instructor like me, as well as request custom team training for you and your organization. All right, let's get back to the lesson and I'll see you at the end.
Now, let's say a little information about square foot estimates. Once a design has reached the early schematic stage, it will start to produce floor plans, elevations, and building sections. This information makes possible the calculation of floor areas or building volumes, which can then be multiplied by appropriate unit costs to produce a square foot or, on rare occasion, a cubic foot estimate. The appropriate unit costs are derived from either in-house sources that track past similar projects or outside data sources. This base cost is adjusted to reflect more project-specific factors. Any actual project data that can be folded into this historic data will improve the accuracy of the estimate. Information regarding structural systems, building height, exterior closure, and overall footprint of the building are all factors that will be assumed by the estimator. If real data are not available, a square foot or cubic foot estimate, while more complete than a ROM estimate, is still quite schematic in detail. It is, however, easy to prepare, taking only a couple of hours. The general assumption for accuracy is plus or minus 15%, better than the ROM estimate because it is based on more project-specific information. Now let's discuss an assemblies estimate during the design development stage. In the latter stages of design, when more information is available, it is possible to configure estimates into a series of systems. This method, called assemblies estimating, uses a system or assembly units of a project. In a ROM estimate, the unit is the number of beds or miles of road. In a square foot estimate, the unit is the square foot area of the project or gross areas of the project. In an assemblies estimate, the unit is the foundation, the roofing, the electrical system, and so on and so forth. Since the units are smaller, the estimate becomes more flexible, but also requires more designer input and takes longer, and costs more money to prepare. However, its accuracy is much better, closer to the 10% range. Usually, the assemblies estimate is done with the uniformat methodology of substructure, shell, interiors, services, equipment and furnishings, special construction, and building site work. However, you also can do it using the master format system, which is the CSI 50-division master format system rather than the 7-division uniformats division setup. I particularly like the master format system better because it gets you more in line with the way you will eventually do your unit price estimate per the CSI 50-division setup. And the assemblies estimate is generally done with approximately 10% accuracy. Let's say a few words again about the assemblies estimate by division. The uniformat method has 7 divisions: substructure, shell, which is the exterior, interiors, services, mechanical, electrical, plumbing, for example, equipment and furnishings, special construction, and building site work. The master format method of 50 divisions has many more breakdowns, but is closely aligned to the way you're eventually going to do your detailed unit price estimate, which is the ultimate goal of your estimate project goal. Finally, let's talk about the renovation of a project. And project estimating can be challenging. Why? In a real world story of renovation. And the reason for that is when you do a renovation job, there are many hidden costs, many unforeseen site conditions. When you take down a wall to renovate an existing condition of a wall, you don't know what's behind it. As-built record drawings sometimes depict what's there. Sometimes those drawings are correct. Sometimes they're incorrect. So many surprises occur in renovation. So in many ways, a renovation project can be more challenging than a new project because of many unknowns facing the structure or the project that exists that you don't know about. So always keep that in mind, that a renovation is always challenging.
Hey there, did you enjoy that lesson as much as I did? If you did, go ahead and give us a like. If you want to see another one, go ahead and subscribe. And if you have any questions or comments, put them below and we'll get back to you as soon as we can. Moreover, is there somebody in your life who really needs this lesson right now? If so, go ahead and share it with them. I'm sure they'll appreciate it. Now, we look forward to seeing you in the next lesson where you can learn even more from the University of Maryland Project Management Center for Excellence. Thanks so much.